Welcome. I'm Tim, I'm the Senior Lab Tech Specialist, and I'm going to explain to you some of the meters in which you're going to be using here, and then we're going to show you how to properly use them. Now, what you always have to concentrate on with electricity is not being able to be shocked. All right, so safety is our utmost importance here. Do not ever stick your fingers, bare or covered, into the electrical box unless you know exactly what you're touching. Let me tell you that you need your safety glasses, and they have to be clear, and your gloves. I prefer these because I can touch and I can feel exactly what I'm touching. You get these big brawny garden gloves and stuff like that, they do not work. So please get the proper gear. 20 bucks, going to save you a whole lot of pain. You're going to notice in this working lab that we have several different types of meters, and they always keep changing. We keep upgrading. Manufacturers send us free meters, so we're going to use what we get. But what I suggest to a student is use all the meters. Don't be stuck on one meter, because when you get out in the real world, you want to know, this is a prime opportunity for you to figure out what type of meter you like. And the sponsors give big discounts to the students, so be aware of that. All right, first we have the field piece. All right, and then we have, in these gray boxes, typically are the fluke meters. All right, those are the two standard meters that we have. The fluke does not have an amp meter probe assessment to it, as the field piece is all in one, as you can see. Also, the field piece comes with a little carrying bag. It's nice. Your leads and your thermometer. Now, in retrospect, here's your leads. Now, it's almost idiot proof, but I wouldn't say that. But the leads are red, all right, for the positive, black for the common, and they should just sit in there and push down in and snap into place. All right, all you have to do is push it down lightly and it comes into play. As you move up, and be sure that you read all this stuff, all right, because it's very, very important. Here we have the Type K thermostat, and that's this little thermometer. What you want to do is look at the tip of this thing. All right, be sure that the weld is still on there and the wire isn't all knotted up. All right, so when I ask you to take care of this stuff, you see how I have it together here. All right, that's the way it should be put back in the bag. If you just shove it and throw it back in there, you're going to damage the leads, and of course that's just money out of your pockets. All right, so let's discuss this. The circle for the meter. Now, all meters basically do the same thing. First, you have the off. Now, I don't want to make high side of this, but when you put this away, please ensure that it's in the off position. May whatever meter it is, use the off position. That's, again, more money. These 9-volt batteries, all right, are getting very expensive. The first one you want to turn to is, in this case, is our resistance, or our continuity, the continuity, and that little symbol is the diode. Now, we don't use the diode here. It's more for electronics. But the wave sign is your continuity. And what's continuity? Continuity is simple. It's just trying to find out if a piece of wire, whatever that wire is, has a complete connection through it. And you'll be using this quite often, so be aware of that. Also, read the instructions with your book. Now, these don't have instructions, but when you go buy a meter, read it so that you thoroughly understand the difference. You'll also see where it will say OL. OL means open line. Now we're going to move over to volts, direct current. This is the auto selector. That means it's going to just do whatever. You can go from 6 or 1 volt DC to the max, which is 600. All right. Now, then you got 300 or 3400 mil, and then you have 340 mil. This is used when you want an attachment on this. All right. Right now we're not worried about that, but just be aware of it. The next one is your Greek symbol for ohms. Ohms will tell you the amount of resistance. As remember, our little wave symbol is just telling us if we have continuity. The point from point to point is in good shape. This will tell you how much resistance that little element or wire or fuse or whatever has in the product. Then you go to Fahrenheit, which is your degrees system, and at that time you would use these outputs right here, 1000 and 340. For most of our business in here in the classroom, you just can stay with 340. Microfarads, MFD, 340. That is the max, so pay attention that you know how much the microfarad in the capacitor. These are your capacitor points. This is what you got to set it on to use it. Now, check, because if it's over 340, you're going to blow the little fuse in this. This is microamps DC, microamps direct current. So this is normally used when you want to check like a spark igniter that you're going to get involved in, or very minute amps. All right. And at this time you would use the prongs down here. When you go to amps AC, you're going to use this clamp version, and that's up here. All right. Now you notice that it's a Cat 3 600 volt or 300 amps. All right. This is, you push down on it, your one wire will go through it, you wrap it around, and it will read it as long, of course, as the motor or whatever wire has voltage going through it. Then you come back up, volts AC. If you're measuring volts in a transformer, out of a transformer, contactors, electrical outlets, stuff like this is where you're going to read it. And then your scale, it will typically tell you what phase you're in, what setting you're in. So always check that. Some people blow up their meters because they go try to test something higher than what it's designed. All right. And then be sure that you turn it off. And I ask that you try to take care of this and be gentle with them. All right. They get a lot of use and they're very sturdy. All right. But you know, the longer we can get something to last around here, the better equipment you're going to get as a student. So if you see somebody mishandling this stuff, let me know. All right. The next thing is the fluke. Now these are our older flukes, but they still serve purpose. The only difference is this doesn't have an all-in-one concept. It also doesn't do temperature. We have a temperature probe system for the refrigeration folks. But the fluke, very sturdy, very sturdy. It works very well. You'll notice that the symbols are all the same. There's no difference in these. That's why you have to memorize them. All right. Then you got your common and your positive lead, and you notice that the common is black, the positive is for volts, ohms, and diodes. If you're trying to work with amps on this, and we don't recommend this because doing this you really have to know electricity, and if you touch it the wrong way and it's not in parallel and you do it in series, you're going to blow a $20 fuse back there. But for starting off, this is very, very attractive little piece of equipment and is very accurate. All right. But again, if you're going to test amps, you would use this holes over here, the plugs, but be sure that you plug it into the right hole. One's going to be in common, the other one is going to be in either 10 amps or 300 milliamps. All right? But again, it works the same way. It has the idiot screen up there. It tells you volts AC, volts DC, volts DC milliamps, ohms, continuity or diode, amps AC, amps DC. And again, just take your time turning this thing off, all right? Just don't be in a hurry, and it will work out smooth for you. This also has a little attachment where you can lay it back and you can see what you're doing. Some of these, the field piece, also have a magnetic flip up so you can attach it right to the unit that you're working with and your hands free. The cables in here are just like every other cable. The Fluke makes what is known as a double insulated set, but very good product. Again, depends on what you want to use it for. But there's a compartment for each one, so please be sure that you use them and you stow them back in properly, so that, and you notice that on these Flukes, the box only sets one direction. All right, these are little zip-up containers. Just put away the equipment properly so that it's ready for the next student. Because remember, what goes around comes around. If you walk in here sometime and the stuff isn't ready, well, yes, somebody shafted you, but you're going to be able to get it squared away. And we don't want to do that. We want the system to work properly. All right? And again, everything is sensitive. I always check to be sure I'm in the off position on all my meters. And it's just a good practice, because what's going to happen is you're going to get out in the real world and you're going to be rushing, and if you don't check that and you go to the next place, now you got to run down to Circle K and get a 9-volt battery, and it's 100 degrees out. Somebody's going to be upset. All right, so what we're trying to teach you is technique and understanding how to take care of your equipment as well. Now we're going to move on, and I'm going to show you how to physically use these meters.